Hello, students. I hope you're well and your family is staying safe and you're staying safe during this time. It's definitely going to be different for a little bit here, but I think we can get through it. And I think a lot of you are going to find that you actually really do like these lessons because you can pause them, you can rewind them, you can watch them again, something that you can't do during live instruction in class. So I'm hoping that these will actually help you a lot with your learning. So today we are going to be covering lesson 7.1 in your book. We're still working with linear equations. We're just taking it up a notch to actually solving for the missing variable. So if you want to pause the video and get your math book, we will be working from pages 197, I believe, through 200 and let's take a look, 202. So I'll let you pause the video and get that. And while you're doing that, I'm going to share my screen with you and get us going here. Close that out. Okay, we'll start at the top. I'm going to have to go back through, erase all this, and go back and erase all that because we're going to start over, except for probably should have paused it and then erased it so that you didn't have to wait for me to do that. Okay, so here is our lesson 7.1. I'm going to put myself over here on the bottom. Equations with the variable on both sides. This is coming from our standard EE7. I can solve linear equations with coefficients, expanding equations, and collecting like terms as necessary. Coefficients, if you remember, are the numbers in front of a variable. So 3x, the coefficient would be a 3, and the x would be the variable. So I'm going to get rid of some of this extra stuff in here that we don't need right now. We're going to be on this page, but not till a little bit later. So let's block that out so we have a little more white space. So we're going to start with question number 2 on page 199. And I will write the question over here. And for those of you that don't have your math book, there was a few of you, that's okay. I'm going to be putting the homework on Google Classroom as well. You will always be able to get it there. So this problem is going to be number 2 on page 199 if you'd like to turn there. A water tank holds 256 gallons but is leaking at a rate of 3 gallons per week. A second water tank holds 384 gallons but is leaking at a rate of 5 gallons per week. Question is asking us, after how many weeks will the amount of water in the 2 tanks be the same? Now I would like to change this to blue. There. Okay, there's a lot of information in this problem. So what I'd like to do is underline the important numbers. Rarely will a word problem have numbers that are not going to be used in the calculations to come to the final answer. Occasionally, a word problem will try to throw you off track and put a couple extra numbers in, but for the most part, you have a safe bet that you're going to use most of the numbers, if not all of the numbers in the problem. So we have 256 gallons. I'm going to underline that. We have a rate of 3 gallons that it's leaking per week. The second water tank holds 384 gallons and it's leaking at a rate of 5 gallons per week. And then it's asking after how many weeks, underline weeks, will the amount of water in the 2 tanks be the same? And I see there's a little typo in there. I don't know if I can fix that, but get rid of the I, it should be of, amount of water. Okay, so now that we have that, we are going to figure out how do we solve that. So step one, when you're solving a problem like this, is to write two expressions for each situation. So we have two situations going on. We have a tank 1 with water, and we have a tank 2 with water. Tank 1 starts out at how many gallons? Let's go back and take a look at our question up here. Tank 1 has, it's underlined, yes, 256 gallons. And a leak is going to represent a minus. And we have a rate. The rate is always the coefficient in front of the variable. So we have a rate of, for tank 1, 3 gallons, and we're going to use W for weeks, because let's let W equal number of weeks, because the problem is asking us for how many weeks it'll take for it to be equal. So now my next step then is to come up with an equation or an expression for tank number 2. So how many gallons does tank number 2 start with? Yep, 384. And it leaks at a rate, a minus of 5 gallons every W or week. Okay, so that's our step 1. Underline that. Getting our expressions all set up. Step 2 then is going to be to set the two expressions equal to each other, because we want to know when they will be at the same amount of water. So we're going to set that up as 256 minus 3W equals 384 minus 5W. Okay, go ahead and pause the video if you need to get that written down and you're doing this with me at home. Now, step 3, we have to solve for the variable, in our case, weeks. So it's our last step, solve for the variable. And by the way, I will share with you these notes that I'm putting together during our session here as well. So solving for the variable, we have done some of this in class, but now we're going to get into how exactly to do that. And we need to, and I'm going to put this in red over here, the goal is always to get the variable by itself. That is our goal, always to get the variable by itself. How do we do that? We do that using inverse operations. What does inverse mean? Inverse is the opposite, correct. So the inverse of up is down. The inverse of left is right. What would be the inverse of adding? Yeah, subtracting. What would be the inverse of multiplying? Yeah, dividing. Just so you know, it's a little awkward. I ask a question. There's nobody there to really give me an answer, but I'm assuming that you're answering at home. So great. Okay, so let's continue on with our solving of this. So I'm going to rewrite it. 256 minus 3W equals 384 minus 5W. So I have to get the W's on the same side of the equals, and I have to get the constants on the same side of the equals. So I think what I'll do first is I will take this 256 and somehow get it over to that side of the equals. How will I do that? Well, I will use, oops, it'll move down on me. I will use inverse operations. So I'm going to have to erase because it's going to go down to the next row anyways. So let's just start it on the next row. So we got a lot more space. Here we go. So I want to get my 256 over to this side using inverse operations. To do that, I'm going to do the opposite of adding 256. I'm going to subtract. Yes, subtract 256 from that side, but I'm also going to subtract 256 from the other side. Whatever you do to one side, you also have to do to the other side. And I'm also going to fix this so that I have single spacing instead of double spacing, line spacing. It's not letting me do line spacing. Well, let's see. I had it line spacing before. Here we go. Single, single. There we go. There we go. Closer together. So now I'm going to underline my two subtraction equations. And by the way, my dog barks a lot. So during these videos, you may just be hearing my dog go crazy, especially if there's a package delivered or something like that, or somebody comes over, he just goes nuts. And if the mailman goes by, he goes nuts. Maybe later I'll bring my dog down, you can meet him. So in the meantime, just ignore it if you hear it. So 256 minus 256 is 0. And we still have our minus 3w. We haven't done anything with that yet. Equals, now we have 384 minus 256. Go ahead and do the math for that. It should come out to, I believe, 128 when I did this initially. Yes, 128. And I still have my minus 5w. Now, I can get rid of the 0 because 0 plus any number or subtracting any number is just the number. So negative 3w is equal to 128 minus 5w. So that's what I'm left with. I'm still not done. I need to now get my 5w somehow over to here with my negative 3w. So how am I going to do that? I'm going to use inverse operations. In fact, let's go back and write the goal is to get the variable by itself using inverse operations. Yay. Okay, now how can I get negative 5w to the other side? Well, I'm going to use inverse operations and I'm going to add 5w because that's a subtraction of 5w. Let's add 5w to this side. But I can't just do that to one side of the equals. I need to do it to both sides so that the equation will stay balanced. So I'm going to add 5w to the left side of the equals, trying to line it up. There we go. Put a line under that. And we now have negative 3w and positive 5w. What is that going to give us? 2w. I heard it somewhere out there in Cyberland. 2w. Yay. Okay. 2w equals, we still have the 128, but over here, if I was to say we have a negative 5w and a positive 5w, won't that come out to 0w? Yes. So plus 0w. Come on. Plus 0w. Not OW, 0w. Okay. Now I'm just going to drop the 0w because 0 times any number is 0 and 128 plus 0 is just 128. So now I'm left with 2w equals 128. I'm still not done because I still have to get w by itself. The goal is to get the variable by itself. It's not by itself. It still has a coefficient in front of it. It has a 2. I somehow have to get this 2 over to that side. I have a different situation now. I have a multiplication problem. 2 and w means multiply 2 times w. So I'm multiplying instead of adding or subtracting as I was above this. So now, what is the inverse of multiplication? Right, division. So I'm going to divide both sides, because whatever you do to one side, you have to do to the other. I'm going to divide by 2 to both sides of the equals. And I'll draw a little line so you know it's division. So 2 divided by 2 on the first side is going to give me 1W. And 128 divided by 2, go ahead and do the math, should give you 64. Now 1 times any number, 1 times W is just going to be the number. So 1 times 7 is 7, 1 times 8 is 8, 1 times 1 million is 1 million. So 1 times W will just end up being W. So we're going to drop the 1. So W is equal to 64. So my answer to the initial question is it will take 64 weeks for the amount of water in both tanks to be equal or the same. There you go. Go ahead and pause the video if you need to get this written down or to try it on your own for a minute and digest it. And then we're going to move on from there. Okay. All right, we're going to go to number 3. At the bottom of page 199, it's the your turn problem again. So I'm going to clear my screen of a few of these things. Clear that. I'm going to clear that. I'm going to clear that. I'm going to clear, well, I want to clear this whole thing here. There we go. I didn't want to clear all of that. I wanted to keep the box. So let's put the box back. I'm going to put the box back. There we go. Okay, there's the box. And I'm going to scroll up so that we got a whole new clean slate here. Okay. Now, the question now is saying, write, and I'll put it over here, write a real world situation that could be modeled by the equation 30x equals 48 plus, oops, it's supposed to be a plus, 22x. This way so we don't split up the equation. There. Okay, now I have to write a real world problem. So I have to model and make a problem for this. There's many, many ways you can do this. Many, many different scenarios. We're going to stick with the same one today, right now. And when you do your homework, I'm sure there'll be multiple different answers. But we have 2 equations. Hello, doggy. We have 2 equations. We have 30x as one equation. And we have 48 plus 22x as the second equation. Maybe you should stop the doggy from barking there. Okay, so the first expression is just 30x. And remember I said that a coefficient in front of a letter is a rate. So let me put that there. That is a rate. And the 22x in the second equation is the other rate. The 48 is going to be a flat fee of some sort. So I'm going to make an expression. Let me just get rid of this rate now. I'm going to make an expression for 30x. And I think I'm going to say that, let's get some room here. For the 30x, we're going to say that Levi is hiring a basketball coach. He's already really good, but he wants to get to be on the NBA. So yeah, so he needs the coach. Levi is hiring a basketball coach. The coach charges $30 per hour. Okay, see where I'm going with this? And Malik is also hiring a basketball coach. His coach charges, what do you think I'm going to say? $22 per hour. That's the rate, right? Plus a one-time gym membership fee of, and I'm going to move up a little bit here, $48. And I'm going to erase this so I have a little bit more room to scrunch this. Oh, didn't need to do that. Undo. And let's move this up so we can fit that equation. Okay, I can move this up 1, 2 as well, maybe. There we go. Okay, so we've got a scenario for both equations. And maybe I'll move this equation up to the top like I have it over here. There. Now we want to make an equation. Now they're both set equal to each other, so we have to finish the real world situation by asking a question. So after, how many hours will Levi and Malik be paying the same amount? Because they each have a different coach, charging different fees. After how many hours will Levi and Malik be paying the same amount? There, we've set up a real world situation problem for question number 3. Okay, go ahead and pause the video if you need to, or if you want to think up a different real world problem, feel free to do that. And we will move on from there to clearing all my drawings. This is homework, that's for later. Okay. Now we are going to be looking at page 200, the guided practice. So we have 6 questions we're going to go through. Question number 1 and 2 is telling you to use algebra tiles. Feel free to look at that if you want. That's on page 197. I feel it's confusing and I'm not going to use it, but if it's something that helps you and you want to take a look at that, feel free to do that. I'm just going to use good old algebra to solve questions 1 and number 2. So number 1, the question is x plus 4 equals negative x minus 4. Now, be careful because there's a negative x in here. Now, I'm going to go ahead to make things easier on myself and put a 1 in front of each one of the variables. Because a variable by itself, you can assume that there is a 1 in front of the variable. So I'm just going to stick that in there just so that we know that there's a 1 there. We can visually see it, even though in my mind, I know there's a 1 there. Now, to solve this, I have to, the goal, put it again, the goal is to get the variable by itself on one side of the equals using inverse, yes, operations. Thank you, Cyberworld. Okay, so to do that, I am going to first bring the 4, oh, I want red, not white. I'm going to bring the 4 over to this side. How am I going to do that? Using inverse operations, yay! Okay, so I am going to subtract 4 from the plus 4 to both sides of the equation. Draw my little underlining here so that you can see the steps. And by the way, it's a good idea to show all your steps so that you don't make any errors. Very good idea to do this step by step. Okay, so positive 4, let me get my little spotlight here. Positive 4 and a negative 4 is going to equal 0. That is correct. So I'll have 1x, because that's still there, plus 0 equals negative 1x. Haven't done anything with that yet. Now what's the next part? So if I go over to this right here, I have a negative 4 minus 4. What is that? Well, let's write it over here. Negative 4 minus 4 is the same as negative 4 plus negative 4. So if you owe me $4 and you owe your mom $4, how much do you owe altogether? Right, $8. So you would owe, you'd be in the hole, negative $8. So if I go back to my equation, I still have my negative 1x minus 8. Okay. Next step is now to get the negative 1x over to this side of the equation. So to do that, I'm going to use inverse operations. So I'm going to, this is a, let's get the spotlight again. This is a minus 1x, so I'm going to add 1x. Do the opposite. So I'm going to come over here and I'm going to add 1x, so plus 1x. And I'm going to drop the 0 because we can drop the 0. And then I have to add my 1x to this side, and I still have my minus 8. And I'm going to underline, and I'm going to underline. I didn't want to underline the equals. Let's get rid of that. Okay. So now I have over here, I have 1x plus 1x. That will give me, I hear it, 2x. We're dropping the 0 equals, now, what is a negative 1x and a positive 1x? Big fat 0, right? Okay, so now we have a 0x minus the 8. Dropping the 0x, because that doesn't matter. 0x is equal to negative 8. Am I done? No, I'm not done because I have to, the goal, find the spotlight. The goal is to get the variable by itself. Let's actually put a colored arrow. The goal is to get the variable by itself. To do that, I have to use inverse operations. So the opposite of multiplying 2 times x is dividing by a 2 to both sides. 2. Okay, so I'll put the little line under there so it looks like division for you. So 2 divided by 2 is going to be 1x. And negative 8 divided by 2 is going to be negative 4. Drop the 1 in front of the x, and I'm left with x equaling negative 4. So that is the answer to the first one. X equals negative 4. There you go. Okay. Now, pause the video if you need to. I'm going to move on to the next problem. I can probably just do a big circle. Oops, didn't want to get rid of that one. Okay, so we're going to move over to the next one. And that is 2 minus 3x equals negative x minus 8. The goal is to get the x by itself. So my first step then is going to be to move this 2 over to this side by the negative 8. To do that, I'm going to subtract 2 from both sides. Now don't get tricked on this. This is another one of those subtracting a negative thing. It's like we did on the last problem. So negatives throw people off pretty easily. Okay, so 2 minus 2 is easy. That's going to be 0. I still have my, trying to point to it, you can't see me pointing. I still have my minus 3x there. Minus 3x. Why is that not showing? Minus 3x equals, still have my minus x here. And now I've got minus 8 minus 2. So let's just write that out here again. We have minus 8 minus 2. What is that the same as? Yep. Minus 8 plus negative 2. So you owe me $8 and you owe your mom $2. Are you in the hole? Yes. How much? Yes, $10, negative 10. So we're going to go put that in here. We have negative x minus 10. Okay, next step, I'm going to get the x over to that side. So I'm going to do that using inverse operations. So I have a negative x here, so I'm going to add a positive x. Remember, there's an imaginary 1 in front of the variable. I'm not going to put it in this time because I wanted you to get used to seeing it both ways. And I have to do the same thing to this side of the equals. So let's see if I can line that up a little bit better. There, best I can do. There and there. Okay, I'm going to drop the 0 because we don't need that. So now I'm left with negative, let's get the spotlight out, negative 3x and a positive 1x. That should leave me with, yep, a negative 2x, drop to the 0, remember, equals, now I've got a negative x and a positive x. That's going to end up being 0. 0x minus the 10. Okay, I'm going to just drop that 0x and say negative 2x equals negative 10. Now, I'm not quite done yet. I still have to get the negative 2 somehow over to this side so that I can use my goal of getting x by itself, correct? So to do that, I have to do the opposite or inverse. We have a multiplication issue, 2 times x, or negative 2 times x. So we are going to use division, which is the opposite of multiplication, and divide both sides by negative 2. A little line under there so that you can see its division. And negative 2 divided by negative 2 is going to be a positive 1x, or just x, equals a negative 10 divided by a negative 2 is going to be a positive 5. So that is my answer. X equals 5. By the way, if I wasn't sure if I did that right, I could plug 5 back into all the spots where there's an X in the problem and see if I end up with a true statement after calculating that out. And if I do, then I know I got the right answer for X. So just wanted to bring that up. You can always check your work. Okay, pause the video if you need to. I'm going to go on to number 3. We're going to write, nope, we're not going to write an equation. We are going to solve an equation. So let's clear some of this while you guys are getting ready. Okay, scroll down, separate paper here. Okay. This one, we'll read it together. At Silver Gym, membership is $25 per month and personal training sessions are $30 each. At Fit Factor, membership is $65 per month and personal training sessions are $20 each. In 1 month, how many personal training sessions would Sarah have to buy to make the total cost of the 2 gyms equal? So we got a lot going on. This is one of these things where we have to do the 3 steps. Step 1 is to write 2 expressions for each situation. Step 2 is going to be to set the 2 expressions equal. And step 3 is going to be solve the equation for the variable. Okay, so now that we have that, let's write 2 expressions. So we have Silver Gym and we have Fit Factor. So let's see what we can come up with. Let's underline important numbers. Silver Gym is $25 per month. Personal training sessions are $30 each. Fit Factor is $65 per month, and personal training sessions are $20 each. And we want to know when the two costs of the gyms will be equal. Those are the important parts. So if we go back to Silver Gym, we have the $25 looks like it's a rate per month. However, the question is only asking us for the total cost for 1 month. So in our case, the $25 is going to be our flat rate fee, or our 25 one-time fee. And then the personal training sessions is our rate. So that's going to be $30 times, we're going to say T for training sessions. So I'm going to say let T equal, I'll put that in there. Let T equal number of training sessions, like that. Okay, so we got Silver Gym. Go ahead and try to do Fit Factor. Okay, so we have a rate of $20 times the number of training sessions plus $20, $65 per month, right? Fit Factor membership, yep. Okay, so we've got that. Now we're going to set the two expressions equal. We don't need that much space in between. So 30T plus 25 is equal to 20T plus 65. Okay, so look at this if we wanted to, so that you can see the steps nice and neatly. And step 3 now is to solve. Since we've gone over a few of these problems solving, now I'm going to go a little bit faster on solving this. We have, I'll rewrite it, 30T plus 25 is equal to 20T plus 65. I want to get the T, the variable, by itself on one side of the equal, so I'm going to first start by moving the constants around. I'm going to subtract using inverse operations the 25 from both sides. Underline there. I'm going to put the equals in there just so you can see there's a division there, just separate side. Okay. And I'm left with 30T plus 0 equals, because positive 25 and negative 25 equals 0, equals 20T. And now I have find my spotlight. I have my 65 minus my 25. So what is 65 minus 25? It is 40, right? Yep. I don't want to underline all of that. Okay. Now I want to get my 20T to the same side as 30T. So I'm going to subtract 20T from both sides of the equation. Which is now going to give me 30T minus 20T, 10T. I'm going to drop the 0, rid of this underlining. Drop the 0 equals positive 20T minus 20T is going to be 0T, so I'll drop that, and I'm left with just 40. Now I'm still having to get the T by itself. I'm going to use inverse operations of division because I have a multiplication situation here. And I'm going to divide both sides by the 10. That's the coefficient in front of the T. I do that. I get 10 divided by 10 is 1T, or just T, equals 40 divided by 10 is 4. So my answer then is after, the total cost, after 4, I gotta look at the question, training sessions, the cost at both gyms will be equal. Over here, there we are. Okay, feel free to pause the video as needed and then come back and we're going to do the last few problems. I'm going to clear all my drawings and slide it down here fresh page. That's homework. Oh, wait, that. Okay. That later. Okay. Problem number 4, we get to write a real world situation. Now, in your homework, you're all going to have different answers. There's multiple ways to come up with word problems. So we're just going to do together these two and use the same word problem. So we have a real world problem of 120 plus 25x equals 45x. So what I'd like to do for this one is I'm going to say that we have DJ Antonio and we have DJ Oscar. Okay, and they both have different rates. So we have this first one, DJ Antonio is going to be represented by 120 plus 25x. DJ Oscar is going to be represented by 45x. So we got to come up with a situation. We have this 25x is some kind of a rate, and this 120 is some kind of a flat fee. So I'm going to say that DJ Antonio charges $120 $, for setup fee, and he's probably got a bunch of lights and cool things like that and sound system, and $25 per hour to crank the tunes. And DJ Oscar, on the other hand, charges $45 per hour to crank the tunes and no setup fee. Who's the better deal? I don't know. I guess it would depend on the number of hours. However, since we want these two to be equal to each other, we're going to ask the question, after how many hours will the costs be equal for DJ Antonio and DJ Oscar? That is a real world problem that we could solve then. And then if we wanted to take it a step further, we could then solve for X. The problem isn't asking us to do that. If you'd like to do that on your own and solve for X for some extra practice, feel free to do that. Okay, and we'll go on to one more problem. This one says, write a real world situation for 100 minus 6x equals 160 minus 10x. So we have two separate expressions on either side of the equals. We're going to say that Gia has a $100 gift card. Now notice how this is a subtraction. And for Starbucks. Each day she buys a $6 cappuccino. I thought I was going to spell that wrong. Let's see. Cappuccino. Okay. And we have Gretchen has a $160 gift card for Collectivo. Each day, that's two L's as well. Each day, she buys a $10 vanilla latte. Okay, where am I getting all those numbers from and stuff? So this is my rate. This is my minus $6 cappuccino. This is my rate, my minus $10 vanilla latte. This is my gift card balance for Gia. This is my gift card balance for Gretchen. So now I have to ask a question since they're set equal to each other. The question would be, when or after how many, see what is X, weeks will, no, days, each day. After how many days will Gia and Gretchen have the same gift card balance? That is a real world problem for that. And then if you'd like to, you could solve that for x. That would be the number of days. Okay. And then the final one, scroll that one down here, is number 6. How can you solve the equation with the variable on both sides? I've been saying this for a bit now. Use inverse operations to get the variable by itself on one side of the equation. Okay. All right, so that's your guided practice. Your homework then is right here. I also put that in Google Classroom. You're going to read back through pages 197 to 200. You're going to look over the guided practice page 200 that we just did. I will also be putting that on Google Classroom for you if you need it. And then on your own, you're going to complete 201 and 202, questions 7 through 12. If you have want to try challenging yourself, do question number 13 and question number 14. You can always email me and I'll give you the solutions to those. I'd like to have one more pre-recorded session, and then what I'd like to do is have a live session where we can get together and discuss the homework and answer any questions that you have from the homework as well. So I'm going to stop sharing, so I'm going to become real big in a minute. There I am. Okay, well, you have a good day. Don't hesitate to email me with any questions you have at all. Feel free to rewatch this video as often as you want, and I will be talking to you soon. Bye.